Let's take some time this afternoon to review decomposition reactions. Now, when you're given these reactions with the AP test, you're given a description of the reaction. You know it's a decomposition reaction because there's only one reactant. So the only thing you have to do is to disassemble. Now, it might say you're going to be heating something. You might hear that it undergoes electrolysis, but what they're saying is your compound disassembles. How it disassembles is by the addition of energy, because these reactions are endothermic. So they're going to say that it was heated or it underwent electrolysis. They're going to say it decomposed. In essence, you have one reactant and it splits up. These are the easiest reactions that we have in the whole set. Okay, there's 4 types that we have to remember. Other than, the good old-fashioned ionic compound disassembles, there's 4 types. A carbonate will always split into a metal oxide and CO2. Always. Carbonate will split up into a metal oxide and CO2. And what happens here is if we have our test tube and our carbonate in it, if you're heating the test tube, then CO2 is going to be produced in the test tube. That shoves out all the oxygen. It goes out of the container. So the test for carbon dioxide is to light a wood splint and shove it inside the test tube. Okay, if you have carbon dioxide in there, then your splint's going to go out. If you don't, sorry, bad idea. A chlorate, for example. A chlorate will always split into a metal chloride and oxygen. The danger for this is that you are giving off oxygen, and then you need oxygen to fuel a fire. So chlorates are very explosive. Metal oxides in water, that's what you get when you heat a hydroxide, and an oxyacid splits up into a non-metal oxide and water. Those are the 4 cases that you need to remember. You need to know what you get when you disassemble a carbonate, what you get when you disassemble a chlorate, a hydroxide, and an acid. Now the acids are a little bit creepy here. If you heat up sulfuric acid, then what you're going to do is disassemble it and basically drive off the water. So to see what you get, literally subtract H2O. When you do this, your hydrogens are going to cancel out and you get 1 sulfur and 3 oxygens. What that means is if you are decomposing sulfuric acid, you're going to split it into sulfur trioxide and water. This works well every time you have 2 hydrogens. Like if we did this with H2SO3, sulfuric acid, you subtract H2O, your hydrogens will cancel out, you'll get a sulfur and 2 oxygens, which means when you disassemble H2SO3, they're going to split into SO2 and water. Okay, same thing with carbonic acid. Carbonic acid is H2CO3, so you subtract H2O, and that's going to give you CO2. So carbonic acid, when you heat it, will disassemble into CO2 and water. Now, if there's an odd number of hydrogens, then there's a little trick. For example, nitric acid. There's only 1 hydrogen, so you can't subtract H2O. So what we do, and this is just a gimmick, is add 2 of these together. You'll get H2N2O6. Now subtract H2O. So there your hydrogens cancel out. You're left with N2O5. So you're going to say that nitric acid splits into N2O5 plus water. And if you noticed, when we did this, we used 2 nitric acids, so that's how we balance it. Dinitrogen pentoxide is said to be the anhydride of nitric acid. Anhydride means without water. Let's try that again with phosphoric acid. H3PO4. It's an odd number of hydrogens. So we're going to double this up. Again, this is a gimmick. There's no chemical meaning to it. And you're going to get H6P2O8. Now, I'm going to subtract waters, but I'm going to subtract as many waters as it takes to get rid of all the hydrogens. So if I have 6 hydrogens, I'm going to subtract 3 waters, which would be H6O3. Cancel out your hydrogens, and you'll get P2O5. That's the anhydride of phosphoric acid. So on the streets, you would say phosphoric acid is heated, and it decomposes into diphosphorus pentoxide and water. And when you balance this, I'm going to use 2 of these guys and 3 waters, and it's going to be a good world. Now, a decomposition reaction and a synthesis reaction are the exact opposites. So if you're ever wondering what happens when you disassemble something, if you can remember how you make it, then you have your answer. A decomposition reaction is endothermic, and a synthesis reaction is exothermic. A decomposition reaction, you start with one reactant only, and a synthesis reaction, you end up with only one product. A decomposition reaction is fun, and a synthesis reaction is funner. Okay, that's it. Don't drink and drive.